see your face. Good, very nice. Okay, any questions, please, on your whatever I covered in my previous lectures? Anybody has got any questions? Last, I think we spoke about the protection from interference.
Yes, sir.
Regarding protection from interference, that means if 10, 12, 15, 20 aircraft are operating, obviously the frequency of a particular transponder and the interrogator is always the same. As such, there is no mutual interference between one aircraft and the other. Reason being that at the time of manufacture, the twin pulses which are being transmitted, they have something known as random time interval between the pulses, which is unique for a particular aircraft. And your aircraft, which transmits a particular type of pulse, will only receive that type of pulse back. So that's why there happens to be no mutual interference. Even any number of aircraft can be using a particular transponder on the ground. We spoke about the slant range, we talked about the accuracy of the system. Now, there's another aspect which all of us should be knowing, is called the saturation of the beacon. When you talk about the saturation of the beacon, that means it is normally said that approximately 100 aircraft can use the DME at any particular time. Now, what does the saturation system mean? What do you think, what gets saturated now? In that, what we have to see is that the interrogator will transmit certain number of pulses. Whatever the interrogator transmits, the response from the transponder from the ground beacon will be the same. If I transmit from the aircraft 10 pulses will be transmitted back from the transponder. If I transmit 15 pulses will be transmitted back from the transponder. So whatever the interrogator transmits, same number of pulses are transmitted back. So when we say that the beacon is saturated, that means there are no more pulses left to give you a particular response. Now, how is this particular thing, how do we reach this conclusion that approximately 100 aircraft can utilize a particular DME? Beyond that, for example, aircraft number 101 will try but will not get any response from the ground. As such, no information will be displayed on aircraft which is 101. It's approximate figure. When we say 100, does not mean exactly 100. This you'll come to know once I give you the details how this is done. Now, once you switch on your DME, when you switch on the interrogator in the aircraft, right? Your interrogator starts transmitting 150 pulse pairs per second. I repeat, once you switch on the transmitter in the aircraft, when you switch on the interrogator in the aircraft, your interrogator starts transmitting 150 pulse pairs per second. Till the time lock-on takes place. Lock-on means you start receiving the information from the transponder. Initially, you will start transmitting 150 pulse pairs, and thereafter the lock-on will take place. As soon as the lock-on takes place, your pulse rate or the rate of transmission becomes 24 pulse pairs per second. Initially 150. As soon as the lock-on takes place, you reduce the transmission rate of the pulses from the interrogator to 24 pulses per second. If due to any reason you have already transmitted 15,000 pulses from the interrogator and the lock-on has not taken place, then the reduction it will be automatically become 60 pulse pairs per second. So they are this 60 pulse pairs is a very rare actually. Most probably lock-on will take place initially, and your pulse pairs will reduce from 150 to 24 pulse pairs. If due to any technical reason the lock-on does not take place and you have transmitted 150 pulse pairs, now the rate will automatically reduce to 60 pulse pairs per second till the time lock-on takes place. And as soon as the lock-on takes place, your pulse rate becomes 24 pulse pairs per second. I mentioned that whatever you transmit from the aircraft, the beacon on the ground, which is the transponder, will transmit same number of pulses. Initially, during the initial phase, when the lock-on has not taken place, which we call the search mode actually, during the search mode, you are transmitting 150 pulse pairs. If you transmit 150 pulse pairs, the ground transponder will respond by transmitting 150 pulse pairs. As soon as you reduce your pulse pairs to lock-on has taken place and you reduce your pulse transmission to 24 pulse pairs per second, the beacon on the ground, that means the transponder will also respond by transmitting 24 pulse pairs per second. The transponder on the ground generates 2700 pulse pairs per second. I repeat, the normal generation, the rate of generation of the pulse pairs at the transponder is 2700 pulse pairs per second. Example, suppose aircraft number 1 comes and switches on the system, the interrogator will transmit 150 pulse pairs. If the interrogator transmits 150 pulse pairs, the ground transponder will also respond by transmitting 150 pulse pairs. That means the balance left at the transponder will be 2550 pulse pairs. Another aircraft comes again in the search mode, transmitting 150 pulse pairs. If this also for aircraft number 2, if you transmit 24 to 150 pulse pairs, the transponder will respond by transmitting 150 pulse pairs. That means the balance at the transponder now will be 2400 pulse pairs. Invariably, what happens is after you have transmitted for a couple of seconds, your lock-on will take place. As soon as the lock-on takes place, you start transmitting from the aircraft 24 pulse pairs. As such, the transponder on the ground will also respond by transmitting 24 pulse pairs. So the combination of these two, normally the search mode and the lock-on mode, it gives you, because most of the aircraft, within a couple of seconds, they come on to the lock-on mode and they start transmitting 24 pulse pairs. And obviously the beacon on the ground also responds by. That's why we say that approximately 100 aircraft can utilize a particular DME. Beyond 100, the beacon on the ground will be left with no pulse pairs to respond back. The transponder can't respond back because there's no balance left. And approximately 100 aircraft are using, and all the pulse pairs are consumed. The rate of generation is 2,700 pulse pairs per second at the ground. Questions, if any? This aspect, as far as the saturation is concerned, approximately, it is said, approximately 100 aircraft can utilize a particular DME, a particular transponder on the ground. Beyond that, the beacon becomes saturated. Saturated means no more pulse pairs are left to give as a response to the interrogator in case additional aircraft come beyond 101. That's all as far as the DME is concerned. I have nothing more to add unless you people have any questions to ask. Otherwise, we'll go to the question answer session.
Okay, sir.
Anybody, any questions, please? As far as anything in the DME, whatever we have discussed so far, as far as the DME is concerned. Otherwise, we will go to the so-called question answer session. I'll give you a couple of minutes to go through the summary of the DME, please. Go through the summary now, and in case you have any questions to ask, otherwise we will, after about 3 minutes, we'll switch over to question answers. I have got 21 questions. Yeah, 21 questions total DME are there.
Sir?
Absent from the class today?
Sorry, sir?
Anybody absent from the class today? Ayman is being absent from the beginning.
Yes, but Ayman is joining today.
He's joined today?
Yes.
Okay. That means everybody is present today? Complete 19 people?
Except for Suren.
Anyway, I'll just we'll go through the question answers and we'll see people in case you I got the nominal roll with me, please. Shall we go through the question answers now, please?
Yes, sir.
Can I ask now you people, Suren, to start with question number 1. Please first read the question and then give me the answer. Suren, can you hear me?
No, sir. Suren is absent, sir.
Number 1, S-U-R-E-N?
No, Suren is absent, sir.
Absent, okay. Izam?
Zam.
Izam?
Yes, sir.
Yeah?
Soalan nombor 1, Zam.
Sorry, sir. I'm still searching for the question, sir.
Okay, fair enough. Anybody who
What's for it?
question number 1, please, can you read? Daya, are you present?
Yes, sir.
Okay, Daya, then can you please read the question number 1, please?
Okay, sir. Airborne DME equipment is able to discriminate between pulses intended for itself and pulse intended for other aircraft because Charlie, aircraft reject pulses not synchronized with its own random pulse.
That's right, absolutely correct. Question number 1, answer is Charlie. And Naina, are you present?
Yes, sir.
Okay, question number 2, please.
A DME beacon having a transmit frequency of 962 megahertz would have a receive frequency of Charlie 1025 megahertz.
Absolutely right. Okay. Question number 3, Gilbert, are you present? Gilbert. Rajesh.
Yes, sir.
Rajesh, question number 3, please.
a VOR/DME share the same first two letters of their respective identifiers. The last identifying letter of the DME is a Z. This means that, bravo, they are more than 600 meters apart but serve the same location.
Absolutely correct, sir. Absolutely correct, Rajesh.
Thank you, sir.
Ayman. Okay, Ayman.
And sorry, sir. I must say he's having a microphone problem.
Okay, then Gilbert.
Gilbert also absent, sir.
Okay, actually, you do one thing, please. You detail people for the question answer. I'll not give the name. You give anybody who is present there in the class. You do the detailing part now.
Aku Azim.
Ah,
Distance measuring equipment is an example of secondary radar operating on a frequency of 962 megahertz in the UHF band. The answer
Absolutely
is
correct. Question
Charlie.
number 5, please.
The DME transponder does not respond to pulses received from radars other than DME because it will only accept the unique twin DME pulses, Charlie.
Okay, good. And question number 6, please.
The range indicated by DME is considered to be accurate to within delta plus minus 0.25.
Very good, very good, very good, very good, very good, very good. Question number 7, please.
The DME receiver is able to distinguish between replies to its own integrations and replies to other aircraft because, Charlie, each aircraft transmits pulses at a random rate and will only accept synchronized replies.
Absolutely correct, sir. Absolutely correct. Come on, question number 8, please.
When the DME transponder becomes saturated, Charlie, it increased the receiver threshold to remove
Okay, fine.
weaker
Absolutely
signals.
fine. Question number 9, please.
an aircraft flying at flight level 250 wishes to interrogate a DME beacon situated 400 feet above sea level. What is the maximum range likely to be achieved? Delta 222 nautical mile.
The formula, what are you applying?
1.25 plus
Okay, absolutely
H1.
correct. Question number 10, please.
For DME and a VOR to be said to be associated, it is necessary for Bravo the aerial separation not to be exceed 100 feet in a DME or 2,000 feet outside a DME.
Okay, absolutely. Who's that?
Xiao Wei, sir.
Okay, okay. Next, please.
Transmission frequency of a DME for a DME and a VOR to be
No,
number
question
11,
number 11, please.
transmission frequency of a DME beacon is 63 megahertz. Removed from the aircraft interrogator frequency to prevent Bravo airborne receiver locking onto primary returns from
Absolutely.
its
Bravo
own
is the
position.
answer. Question number 12 is a repeat question of question number 6. So let's go to question number 13 now, please.
For a VOR and a DME beacon to be said to be associated, the aerial separation must not exceed 30 meter in a terminal area and 600 meter outside the
Okay,
terminal
right.
area.
Absolutely. Question number 14, please.
DME is a Bravo secondary radar operating in the SHF band, UHF band, and use twin pulse in order to obtain range information.
Yeah, Bravo
Answer
is the
Bravo.
answer for this, sir. Question number 15.
The receiver of airborne DME equipment is able to lock on to its own reply pulses because, Charlie, The aircraft receiver only accepts reply pulses which has the same time interval.
Okay, absolutely correct. Question number 15. I would like everybody to do next question, please, on your own by application of 160 rule. I would like everybody in the class to do this, please. Hazik, I can see you.
There is a what?
Yeah, okay, I can see. Okay, fine. A bit louder, please.
So isn't it answer number 16 is alpha?
Answer is alpha 042, right?
Yes, radial.
Absolutely correct. Next now. Okay, next question number
17.
Yeah, question number 17. Who's answering? Who's trying to answer that?
Hakimi.
Um, 17, is it Bravo, sir?
No, it will not be Bravo because it is just because mark Bravo, it is not Bravo.
Because I marked that answer.
You think and give me an answer, please. Answer is not Bravo because Bravo is not right.
Alpha?
Alpha is the answer because it's nil-wind conditions. Once you have intercepted the required track, you'll turn left onto 045 and carry on flying 045. Nil-wind conditions, there are no drift. That means your required track is 045. As such, you will maintain 045.
Oh,
Assuming
nil-wind. Okay.
Right? It is still air conditions. Regaining the center line, it will be necessary to make the following alteration of heading. Once that means you have intercepted the track now. As such, and there is no drift, there's no, as such, whatever the track is there will be your heading. You turn on to 045. Right on?
Sir,
okay, please. Any questions?
So return back to question number 16.
Yeah.
So actually, what's the purpose of they giving us the information about the DME range of 40 nautical mile?
Oh, no, that is 160 rule. That's applicable of 160 rule. That's why we have not given the answer to this particular question. If you apply 160 rule, what would be the distance you are from the beacon? This is what the question is.
So the question is asking about the radial of the aircraft from the VOR, from beacon.
Radial of the aircraft.
Yes,
now,
correct.
The 045 is the selected track.
Correct.
And 045, you are from the beacon?
Yes, correct. So we
that
actually
you are in 045 sector?
Yes, correct.
And the needle tells you turn right 3 degrees.
So, but you say
1.5 dot.
1.5, because you say 1 dot equal to 2 degrees.
The circle there
Okay.
The center circle happens to be dot number 1.
Dia mula tengah.
Oh, okay. Okay.
The circle is dot 1 and thereafter dot number 2. The needle is in between these two dots. That
Oh,
means
right.
1.5 dot, 3 degrees.
2 degree, okay.
The circle inside in the center happens to be dot number 1.
Okay.
That's why you will see 4 more dots are there, including this becomes 5 dots.
Okay. So technically it's radial, it reflect by 3 degree lah.
That's right.
Okay, sir. Thank you.
Okay. Now next, please. Carry on.
Jai.
DME operates in the UHF frequency band. It transmits.
A bit louder.
DME operates in the UHF frequency band. It transmits twin pulses, which gives it the emission designator of PON. Bravo.
Okay. Question 18, bravo is the answer. Question 19, please.
Referring to DME during initial stage of the search pattern before lock-on, the airborne transmitter transmits 150 pulses each second. Bravo.
I beg your pardon, a bit louder.
Bravo, sir. 19, referring to DME.
150 pulse pairs per second in the search mode when the lock-on has not taken place. And once the lock-on takes place, you reduce the transmission to 24 pulse pairs per second, right?
Correct, sir.
Very good. Absolutely right. Now, question number 20, please.
DME and VOR are frequency paired because the answer is Charlie. Cockpit workload is reduced.
Okay, very good. Absolutely correct.
A DME receiver is able to distinguish between replies to its own integration, pulses, and those intended for other aircraft using the same transponder because Charlie. Each aircraft transmits pulses at a random
Okay.
rate.
Answer is given there itself. Okay, fine.
Yeah.
Okay, fine. As far as the DME is concerned, we have finished with the DME now. Any questions, any doubts, any clarifications required before I proceed on to the next topic, which is secondary surveillance radar.
Sir, can you explain on question number 15?
15?
15, correct.
Okay, the receiver of the airborne DME is able to lock onto its own reply. I mentioned that suppose, for example, the whole batch 71, each pilot is sitting on one aircraft and flying around Malacca. Now, Malacca has got a DME. For example, Malacca has got a DME. If Malacca has got DME, all of you will tune to station Malacca. All 19 aircraft will be tuning to a station which is Malacca. And as such, the frequency will be the same. Now, if the frequency of the transponder and the interrogator happens to be the same, there is every possibility that your transmission is likely to mingle or mix up with the transmission of the other aircraft, because all of the aircraft are transmitting on the same frequency. All the transponders are receiving on the same frequency. As such, what happens is, in case of the DME, a special care is taken at the time of manufacture or installation of the DME in the aircraft. That each aircraft has got a separate time interval, which has got random time interval between the twin pulses. As such, whatever you transmit from your aircraft will receive only that type of transmission. Whatever the random time interval is been allotted to you, it is unique for your aircraft only. Other aircraft will not have the similar system. As such, your aircraft will receive only the pulses which you transmit from your aircraft. As such, when we talk about question number 15, it talks about question number 15. I'll read the question again, please. The receiver of the airborne DME equipment is able to lock onto its own reply pulses because the aircraft receiver only accepts reply pulses which have the same time interval between successive pulses as the pulses being transmitted from its own transmitter. Same thing what we are saying is the time interval or the random time interval between these particular pulses, the aircraft will recognize. And you will receive, your aircraft interrogator will receive only those pulses which you have transmitted. Okay? Hello?
Okay, sir. Got it. Thank you.
Got it. Okay. Anybody else? Any other question, please?
Okay, sir.
Good. No questions, no nothing. Now, next we switch on to what we term as secondary surveillance radar. Now, before I touch this particular topic or we go on to this particular subject, as the name suggests, it follows the principle of which is called the secondary radar principle. As such, you transmit and receive on two different frequencies. Number one, this is one navigation system which you are going to use the day you enter any commercial aircraft. Tomorrow, once you start flying, once you graduate from this academy, take up a job in any of the airlines, once you sit in the cockpit, the first system which you are going to operate happens to be this, which is called the secondary surveillance radar. This is basically a ATC radar. This is basically a ATC radar, and ATC has to tell you the whole system is coded actually, and ATC will tell you, okay, punch so and so code. I'll brief you once we discuss the subject in detail. I'm just giving you the overall picture how the system operates. And this is being a ATC radar. ATC basically requires identification and to know what is your height, what is your direction, where are you going, what is your call sign, etc., etc. ATC wants to know all these information. And the difference here is when you talk about it follows the secondary radar principle. Only difference here is, in this case, the interrogator is installed on the ground and the transponder is installed in your aircraft. Unlike DME, where the interrogator was in the aircraft and the transponder was on the ground, in the secondary radar principle, as far as the secondary radars are concerned, here the interrogator is on the ground and the transponder is installed in the aircraft, and you transmit the transponder, the interrogator transmits on a particular frequency, and your aircraft response will be on entirely a different frequency. If you see the diagram on page number 1 itself, on secondary surveillance radar, you'll find the two frequencies given. One is for the receiver, the other is for the transmitter. You're talking about airborne equipment, etc. If you have a look at this, you'll find that there are two different frequencies. That's why it is called the secondary surveillance radar. The complete control of the system is with the ATC. The pilot of the aircraft can use this navigation system for any other purpose only in an emergency. Otherwise, this particular services are normally provided for the ATC. ATC will tell you what are to do, what are codes to punch, and whatever information ATC wants from you will accordingly. As I said, there's no verbal communication. You and the ATC do not talk at all. ATC just tells you punch code so and so, so and so, so and so, and you punch that particular code in the aircraft, and on the ground, the ATC chap will receive whatever information they so desire from the aircraft. This is basically the basic system, how the system works. We will discuss the ingredient or the intricacies of the system in due course. This is basic as far as you're concerned. So what I want to highlight here is, this is one navigation system which you have to understand right from the beginning, because as soon as you sit in the cockpit tomorrow, you are going to operate this, because the ATC is going to tell you, okay, switch on your weather, your surveillance radar, and please punch code so and so, so and so. That's all. So you have to be familiar with this particular system. As such, please be slightly more vigilant and careful in what we talk about. It is, though it is called the secondary radar principle, it uses both the primary and the secondary radar principle. I repeat, though it is called the secondary radar, but it uses both the principles of the primary radar as well as the secondary radar. Primary radar provides you with the information regarding your location, where you are, your bearing and distance from a particular, as we have discussed in the primary radar system. You transmit on a frequency and receive the information on the same frequency. This SSR or surveillance, secondary surveillance radar is a mixture of primary and the secondary radar, though it is called secondary radar surveillance, secondary surveillance radar. But it uses both the principles. And principle number one is that the primary radar gives you the position of the aircraft. Thereafter, the aircraft height, destination, point of leaving airspace, ETA, etc., are provided by the secondary radar principle. Right? Now, in this case, if you get onto page number 2 of the secondary radar principle, where the aerials are drawn. Can you? Hello?
Yes, sir.
Page number on the secondary radar where the pictures are drawn of the aerial,
Okay.
please.
Hold on. This one, sir?
Yeah, this one, yeah. You see the
Okay.
aerial, these has the aerial marked here. The larger size of the aerial happens to be the primary radar where the position of the aircraft is marked, and the smaller on the top you have, which is called the secondary radar. On the bottom. Now, I would like somebody in the class to read the advantages of SSR, please.
Advantages of SSR. SSR has the following advantages over primary radar. 1. Requires much less transmitting power to provide coverage up to 200 to 250
Why?
nautical miles.
Why? The obvious reason is one-way travel of the radio wave. No echo is required. That's why you have the advantage of you require much less power. It's not dependent on the aircraft echoing surface at all. As mentioned earlier, gives clutter-free information, etc., 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 etc. The complete transmission is on in case the frequency of the PRF. Next page, please.
Sorry, sir.
Can you make the font a bit larger? Yeah, okay. Now frequency of the here in the UHF band 1030 and 1090. That means there is a difference of 60 megahertz. In case of this DME, there's a difference for 63 megahertz. In this case, the difference is only 60 megahertz in between the transmission and the reception. The complete transmission is in modes and codes. We have 5 modes available. They are called Alpha, Bravo, Charlie, Delta, and Sierra. Again, the whole SSR transmits on 5 different modes: Alpha, Bravo, Charlie, Delta, and Sierra. As far as you and I, or the commercial aircraft, are concerned, we use mode A, C, and S only. Remaining codes are considered confidential secret, meant for military aircraft only. SSR modes, transmitting on 5 different modes: Alpha, Bravo, Charlie, Delta, and Sierra. As far as commercial aircraft are concerned, we basically use only mode A, C, and mode S. The purpose of mode A is identification of the aircraft. basic identification. When you talk about what is the purpose of these particular modes, the basic aim, basic mode, basic aim is you have to identify the aircraft. Who are you? Which aircraft is flying now? So if you have punched mode A, automatically your so-called information is displayed on to the controller screen in form of identification. Who you are, where are you from? And mode C is basically the pressure altitude information. Whatever height you are operating at, or whatever pressure altitude you are operating at, mode C will display that, and the controller on the ground will know what height you are flying at. And mode S is basically an improvement on mode A and C. This is a basic improvement on mode A and C. Right? Can you go up, please? Yeah, that's okay, okay, right? Now, when we talk about the interrogation, when we talk about that is a special identification switch, right? On mode A, which is called the squawk. If there is a large traffic in the area where the controller is controlling, they want to know the specific information regarding your information, and the controller on the ground will ask you press squawk or press identification. As soon as you press, there's a particular switch on board the aircraft which is called the squawk switch or the identification switch. Once you press that, your information on the ground will start blinking. Your position, and the duration of this particular blinking happens to be 20 seconds. On mode A, you have a special switch which is called the squawk switch, which is basic for identification in high intensity traffic area where the controller is unable to identify you. And in case the aircraft wants information on you, on where you are located, will ask you to press the squawk or the identification. The duration of this identification is 20 seconds. And once you press this particular switch, on the controller screen, your information will start blinking so that the controller can immediately identify who you are. The modes or the codes are given to you by the ATC. Number one, invariably, mode and A and C are normally operated together, unless specifically told to you by ATC. Otherwise, as I said, the control of the aircraft is directly by the air traffic control system. They tell you what modes, except during the emergency where you are entitled to be on your own, and you have to inform the ground controller what type of emergency you have. For each type of emergency, there are separate codes which we will discuss slightly later today. You press those particular codes only on the emergency. Otherwise, mode A and C are normally operated together. Numbering of the numbering of the codes is from 0000 to 7777. Total number of codes available in a particular mode is 4096. I repeat, normally A and C are the modes which are used together. A is for identification, C is basically for height, pressure, altitude. Normally ATC will tell you, okay, press code so-and-so, so-and-so. The numbering of the code starts from 0000 to number 7777. The first code will be 0000, and the last code will be 7777 in mode A and C. The total number of codes available in a particular mode, A and C, is 4096. Hello. Morning, Cherry. 1 o'clock, please. 1 o'clock, 1 o'clock. Chilpia. Yeah. No, because I'm having a class. I'm having a class till 1300. Come on, 1300. Okay, soda is available. Right on? Hello. Hello.
Yes, sir.
Question, please.
Hi, sir.
Yeah. Go ahead. No, they're not having. Just bring the pack. They'll take it home. No, please pack them separately because they want to take them home. Nobody wants to stay here. Hello.
Yes, sir.
Can you hear me now?
Yes, sir.
Okay, now it's better because I was not wearing the earphones.
Oh, okay. Sure.
Now I've just put the earphones on. Now I said that the numbering of the codes is from 0000 to 7777. Total number of codes available in a particular mode is 4096. You should have a question.
Why does it contain 8 or 9?
I beg your pardon?
Why this code doesn't contain 8 or 9?
See, no, I said they are starting from 0000 to 7777.
Okay.
But number of codes available is 4096.
Okay.
That means the code should be actually, if you talk about the normal sequencing, then the number of codes available should be 7777 because you're starting from 0000 to 7777. But codes available is 4096 only. As such, wherever figure 8 or 9 appears, that particular code is not available to you. Wherever figure 8 or 9 appears, that particular code is not available. That's why you have number of code which is 4096.
Okay.
Right? Next page, please. Next page, further down. We speak about mode C now. Mode C basically is for the height, right?
Okay.
Now, again, mode C also has got 4096 codes available. Whatever code you have selected, in case you are on mode C, whatever mode you have selected, the height information will always be displayed on this particular mode. I repeat, whatever codes you have selected out of 4096, the ATC will tell you, okay, mode C, select code so-and-so, right?
Okay.
Whatever code you have selected, in middle of the code selection, the height information will always be displayed on the controller screen. We'll exactly know what the height of the aircraft is if you are on mode C. Point to note for everybody is, and when we talk about mode C operation, before the ATC utilizes your aircraft for any purpose, the aircraft, the controller on the ground will check with you your height. There will be height displayed on the screen of the controller by mode C system. And physically, the controller will ask you, request your altimeter reading.
Okay.
If the altimeter reading differs by more than 300 feet, mode C will not be further utilized. Or the controller will tell you, switch off mode C. If the height difference indicated by you and what we see on the screen is more than 300 feet, in your book it is written 200 feet. 200 feet is applicable in America. As far as the YASA is concerned, we follow a pattern of 300 feet. Question, doubts, clarifications?
No, sir.
Okay, good, very nice. Now, as far as this is concerned, SSR operating procedure, we have already, operating procedures are very simple. Before you actually start, the ATC will normally tell you, okay, punch code so-and-so, so-and-so. Number two, you will remain on the same code throughout till the time told by ATC, okay, change. As I mentioned earlier on, the complete control of the SSR is by the ground controller. They give you the modes, they give you the codes, and you have to remain on the same code what is given to you by the ATC, unless the ATC tells you, okay, change. Number two, I also mentioned about the height difference. If the height difference given by the pilot, by you, and the indication on his screen, if the difference is more than 300 feet, the controller will ask you, please switch off mode C. That means there's no more reliable mode. This is not giving you the correct height information. Mode A and C are normally used simultaneously, and at times when ATC will tell you, okay, press SCOP identification mode C, etc., not required. Right? Next page, please.
This one, sir.
Yeah, we'll go slide above. Fruiting and the bottom. Fruiting and garbling are the two actually errors of the system. Slightly above, slightly more. Yeah,
This one, sir.
okay, fine. Fruiting and garbling are the two areas where you have a problem. That is, fruiting means if your aircraft is being picked up by two different radars on the ground. That means if you are in the pickup zone of two different radar screens on the ground, there will be some sort of a confusion as far as this particular confusion or unsynchronized in time. You have tuned a particular SSR, but you will be picked up or you will be shown on the screen of the other aircraft, other control of radar screen on the ground, which is called the fruiting. And the garbling happens to be if the aircraft happens to be too close to each other. Right?
Yes, sir.
Next are whatever you see below that happens to be the emergency codes. As I mentioned, that mode A is applicable for identification and the emergencies. These are the various codes available. pilot is independent as and whenever you have a problem of any of these particular nature, what is indicated on the right side, you press a particular code and the ATC on the ground will come to know that you have so-and-so type of emergency on board your aircraft, and whatever assistance or guidance can be provided by you, by the ATC on the ground, will be provided to you if you happen to be in any of these so-called problems. Try, in case try, I said, remember these codes by heart. If you cannot remember them, please carry them in the aircraft whenever you go for flying. Now we spoke about mode S now. Next page, please. Mode S, yeah. Now mode S, as I said, is basically the number of codes available in A and C are 4096 each. As such, these codes are considered too less. Mode C has got no limitation as far as the codes are concerned. Large number of modes and codes are available as far as the system is concerned. Mode C, mode S is basically improvement on whatever you do on mode A and C. It is nothing fresh, nothing great. Only thing is number of codes available are much more. And otherwise, there is no basic elementary difference as far as the usage of this is concerned. And it's basically more reliable, more accurate, and more energy. Hello.
Yes, sir.
I can hear some background noise now.
I'm sorry, sir. Yeah. So I will keep my mic mute in case I need to talk. I will unmute it.
Okay, fine. Absolutely fine.
Okay, sure.
Okay. Next page, please. Last page on this. What is true for, yeah, this on the top, please. Ambiguous aircraft identification. This is what the mode S is all about. The difference in when you talk about number one, there's no limitation as far as the number of codes, no shortage of codes available. System is more reliable, and especially identification is considered better in mode C than mode A, and mode A basically. That's all as far as surveillance radar is concerned. I would just like to go through the question answers, please. On next, just go through the summary first. Just go through the summary. I would like the class to go to the summary, everybody. And in case you have any questions to ask on SSR, I will try and answer them. Otherwise, we will just go for the question answers. Okay. Let's go to the question answers, please. Question. There are only six questions in this. Question number one is answer is alpha, because I don't expect you to remember the various codes at the moment, right? Let's start with question number two, please.
Secondary surveillance radar is a form of secondary radar with pulse type emission operating in the UHF band delta.
Correct. Delta is the answer, absolutely correct. Question number three, please.
If the SSR transponder ident button is pressed, delta, an identification found is ultimately
Delta is the answer. Question number four is Bravo. It is 300 feet. Okay, right?
So question number 5, is it Delta?
It is Delta. And question number 6 is Charlie. Secondary radar requires a target which will resolve. Yes?
Yes, sir.
Okay. Anybody, any questions, please? Anybody, any questions, any doubts?
I think that's all, sir.
Or anything else? Time is 36. I got another 25 minutes to go.
Yes, sir.
All right. Now what I'll do is I'll try and finish this particular so-called in case you do have no other questions regarding SSR, I will go ahead with the ground control.
Book 13, sir. Chapter 13, sir.
Yeah.
Okay.
Are you people ready? Are you people mentally set? Okay.
I need to download the book.
Not necessarily. Anyway, I'll you try and download. In the meantime, I'll just give you a brief on how the system works. When you talk about the ground control approach or the radar assisted approach.
Okay, sir.
Radar assisted. But I can hear some background noise. Are these people talking in the class? Hello?
No, sir. I think it's a background noise. I will mute my mouse. I will mute the audio.
Okay. I can, otherwise it's okay. Now, when we talk about the ground control approach or GCA, this basically is very similar to ILS. Only thing is, the difference here is, in ILS, actually you have to look at the equipment on the aircraft and react accordingly. In case of GCA, the controller on the ground keeps telling you, do this, do that, do this, do that. Turn left, go up, go down, etc., etc. The only difference when you talk about it is used in bad weather conditions, and it's totally a radar-assisted approach. In case of bad weather conditions, when the weather happens to be bad, then radar helps you in bringing the aircraft down to the touchdown point. Just like instrument landing system does. Only difference here is, in case of instrument landing system, you have to look at the equipment, and the equipment will tell you what to do, whether to turn left or turn right, or go up or go down. Similarly, here also, only thing is, you don't do anything. The controller on the ground will tell you, okay, turn left, turn right, or go down, go up, whatever the case may be. Try to keep you on the center line and on the so-called your path so that you can land the aircraft. This is the difference between the GCA and the ILS. Otherwise, this is one navigation system which one uses in case of bad weather conditions, in case your unable visibility is poor, you can't see anything, with the help of the radar, you are brought down. I'll give you a very brief picture on this. This is actually divided into two parts. One is called the surveillance part and the other is called the precision part. That means there are two different type of radars used in case of, now initially, say for example, you are coming back to Malacca. Malacca has the GCA and you want, because the weather happens to be bad at Malacca as such, you want to utilize the radar services to bring the aircraft down, to assist the aircraft in coming down back onto the runway. As I said, the whole thing is divided into two parts. One is called the surveillance. Surveillance controller is different, surveillance radars are different. Initially, when you are about 100, 150 nautical miles from Malacca, you will request Malacca for a radar-assisted approach or the GC approach. And after the initial identification, there are various methods of, now the surveillance radar will come onto the picture first. You, as it is, you are 150 nautical miles now. The surveillance radar will pick you up, and once you have been identified by the surveillance radar, the aircraft will guide you towards a particular aerodrome where you intend to land at. We'll tell you, okay, steer heading 0, 0, 0. Now descend down to 25,000 feet. At the moment, you are 150 nautical miles, and your height happens to be 35,000 feet. Descend down to 25,000 feet. Carry on steering 0, 0, 0. And during this particular brief, the surveillance radar controller will give you a detailed briefing regarding the airfield information and keep guiding you toward the aerodrome, asking you descend, descend, descend. The controller, surveillance radar controller, has you on the screen, knows you where you are, identifies the aircraft, keeps it guiding the aircraft, and will brief you on the normal conditions at the aerodrome. Surface wind, QNH, etc., etc., etc. Visibility conditions, raining, not raining, low cloud, whatever the situation is, will be briefed. One other aspect which the ATC surveillance chap will brief is in case you have an emergency while doing the let down. What are the actions to be taken in case of an emergency? Especially RT failure. Because the whole system is totally dependent on the RT. The surveillance radar controller will bring you up to what we term as closer to the airfield, bring you down to the downwind, ask you, okay, turn heading so-and-so, you are on downwind now, turn heading so-and-so. And please carry out your downwind checks. You carry out your downwind checks and fly further, maintain undercarriage down, etc., 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 whatever the case may be, and you carry on. And this is the stage where the surveillance controller will hand you over to a radar controller, which is called the precision radar controller. Now, this precision radar controller has got in front of him two different scopes, two screens, one to guide the aircraft as far as the localizer is concerned, and the other is glide slope or the glide path. Two different screens. Once you have been handed, and you will be told, okay, now I am handing you over to the precision radar controller. Different location, different person, different radar. And this particular precision radar controller has got two screens. One is called the localizer screen, the other is called the glide slope screen. Just like you have in the ILS, right? And okay, we'll ask you, okay, you have carried out the landing checks. Now I have pick up on you, turn base leg, turn left now. Okay, turn finals. You are on the final approach, and around 5 to 6 nautical miles during this approach, the controller on the ground will tell you, okay, maintain total RT silence. That means you will not respond to any communication now. And looking at the screen, the controller will guide you whether to turn left, right, etc., 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 and keep guiding the aircraft, and will bring you down to what we term as the decision height. And at decision height, you will be asked a question: confirm aerodrome in sight, confirm runway in sight. If you have runway in sight, you will obviously respond back, okay, airfield in sight. Can you hold on for a minute, please? I'll just open the door. Hello? Hello?
Yes,
Sorry,
sir.
sir.
Yes, sir.
Now, can you hear me?
Hello.
Yeah,
we
we
can
can
hear.
hear.
Did you hear what I said about?
You wanted to.
No, I just want to open the door.
Yeah,
Okay,
we'll
sure.
wait.
Okay,
We'll
sir.
wait for you, sir.
Okay, sir.
Okay, sir. No problem.
Please come, please come, please come. Has he brought the food yet? No, he has. He just asked me. He was also a bit confused whether to bring it combined together or. No, we're not. He's an idiot. Keeps sending various messages. Aja. Come, we have a beer. Can you start the beer, please? Yes. Hello.
Yes, sir.
Yes, sir. We are here.
Yes, sir.
Yes, sir, we are here.
Any questions on the? Now this is how it is, and if you are on the final approach, and once you have reached the decision height, you will be asked, okay, confirm runway in sight. If you have runway in sight, you go ahead and land, and you have to tell the GCA controller that, okay, runway in sight now. In case you do not have runway in sight, you will be asked to open power and go around again. Hello.
Yes, sir.
Sir.
Okay, fine.
Okay, sir.
Now, this is how the GCA approach is done. Remaining part we will discuss in the next class. All your GCA approaches are to be on QFE. No, class now. Hello.
Yes, sir.
Okay.
Okay, sir.
Okay.
Remaining, I'll cover on next whenever my class is, right?
Okay.
Got it, sir.
Nice. Have
Sure,
a nice
sir.
day. Good day.
Yes.
And
Thank you,
thank you
sir.
very much.
Thank
And
you,
thank
sir.
you very
Thank
much.
you. Have a nice day to you, sir.
Sir, take care, sir.
Thank you, sir. Take care,
Stay
sir.
safe, sir.
Vitamins, good for your immunity.
Yeah. Okay. Okay. Thank you.
Vitamins. Good food also, sir.
Okay.
Okay, take care, sir.
Thank you so much.
Thank you, sir.
Thank you, sir.
Don't forget your vitamins.
Yes, sir.
Lepas ni ada kelas pukul 1 kan? Alamak.
Serius lah?
Ya, kelas
Atau
Don
pun
dia
pukul 3.
1 kan?
Satu.
Aduh, sekejap aku nak create meeting room.
Oh, aku masuk lambat dia, tak tahu.
Ya.
Zam, cakap dengan aku Zam.
Kau bilik je awal.
Dia nak bawa kelas aku apa?
Dia tukar bilik lah. Tukar room.